Welcome amigos. So in this class we're going to be looking at support vector machines, and also we'll be looking at hyperparameter tuning. We'll do some hyperparameter tuning with support vector machines, and the same method applies to every other classifier that has hyperparameter you can tune. And then I'll be using some tricks here so you can understand what I'm doing. You need to follow and pay attention because this class is going to be very informative. So let's get started. First thing we do is we import our libraries. I think I should. I want to increase this to 150. Yeah. So import our libraries and then we get data. Remember I said I'll be using, but then I'm using this data this time around. I'm not using the Titanic CSV. I'm using this data I got from UCI DataSet, UCI machine learning repository. Then moving from here, I do the train test split as usual because the dataset is actually very clean, very clean. Then drop as usual. You doing your X and your Y, your feature column, which is the X, and your target column, which is the Y. Our feature column is everything aside the risk column, and our target column is only the risk column. Our feature column everything aside the risk column, and our target column only the risk column. So we pass that into the train test split function. We specify a random state here. Now the random state is just to ensure that we get a consistent value. If there is no random state specified, when you train your algorithm all over again, which is what happened when I was training the KNN, while I was making the notebook, I didn't add the random state. So it's very important to add the random state so as you have a consistent answer. So let's run this. Alright, and we continue from here. We train the support vector classifier. Now we need to pay attention. So from sklearn.svm, so this is, I've just seen this one for the first time. sklearn.svm, we import SVC, capital letter S, capital letter V, capital letter C. Then we call it our model. We instantiate it by calling it our model. Model is equals to SVC, nothing in the bracket. Then model.fit. It's just a warning, don't worry. And I believe we understand everything these last three cells are showing because these are the same things we've been doing in the past three classes. Then predictions and evaluations. So predictions, which is also the same, what we've done. So we just call it predictions, and then we do explain the classification report. Alright, so here we want to check how far our algorithm performed, and here we can see it performed 96% accuracy. The accuracy score is 96.55%, and perform very well. But then let's see, 6 and 2 is good, but then we can make it better. So let's see how we can make it better. So we print that, and then classification reports is what this is what I reading this. Let me see. Alright, so as you can see, everything looks beautiful and fine, but most of the time you want to spend your time studying this table because it tells whether your algorithm is performing well or whether your algorithm is performing awfully bad. So basically, now we move to grid search CV, which is our hyperparameter tuning, right? Which is our hyperparameter tuning. So what you want to do first, which is our hyperparameter tuning, which is the part which you need to pay attention very well, because this can actually determine how well your algorithm performs, and it can change your story from bad to awesome. So basically what it does is that it takes in different parameters. Now let me take you back to when we were instantiating the support vector classifier. If I press shift and tab on my laptop, if you're on Jupyter Notebook and I press shift and tab, so you should be seeing what I'm seeing right now, right? So after pressing shift and tab, the first classifier we trained used the default arguments, which is C equals to 1, kernel RBF, and all these other arguments. But most of the times you don't want to just tune any argument anyhow. So in this class we are just going to be tuning The C argument, which in what we trained earlier was just 1. Right, so is it? Yeah, was 1. The gamma, we are going to be tuning these two, and the last thing we will be tuning is the we are not really tuning this because it's the same, but we can actually add other ones to it. But then let's do it at that, because actually your computer is going to lag. This will take a lot of time. So we have grid search CV, and I think I should do randomized search CV as well. Yeah, randomized search CV. So the difference between grid search CV and randomized search CV is that grid search CV does the search one after the other. Like it goes through 0.1, it will say for C equals 0.1, then it will go for gamma 1, gamma 2 at C equals 0.1, gamma, and every other thing. And then for C equals to 1, it does the same thing again for C equals to 10. So which means that if we add other hyperparameters, that have done for C equals 0.1, for gamma equals to 1, for this equals to that, and then to continue like that for every one of them. That's grid search CV, and it will run through everything like that. So it takes time. But a randomized search CV doesn't take so much time, but it doesn't go through everything. It just jumps and take things at random, but you can specify the amount of things you want it to take, the amount of samples you want it to take, and then it returns the best out of the ones it sampled. So I'm importing both of them, right? Then I set my parameter. Remember, you have to set your parameter grid first, which is going to contain the name, the name of the argument, and the a list containing the input you want to tune the argument based on, and like that. Then after that, we import our grid search CV. So grid search CV SVC. So this is what we want to do. Another thing about grid search CV and randomized search CV is that after the old training, you can actually take it as if it is an algorithm, as if you trained another SVC algorithm. So basically, you can just use it instead of us to take the parameters and start training another one. We just use it directly, but you see what I'm talking about very soon. So when we do this, when I run this now, it's going to take some time, but I think it shouldn't take so much time. That's why I'm not using the Titanic dataset, I'm using this dataset. So when I run this, it shouldn't take so much time, and as you can see, I just instantiated that. Then we go down. Now this is what might not take so much time, but then you see what will be happening, right? You see that was very fast, but if your data set is large, it won't be fast. You can see all it did. It was training based on all these, and it was scoring, as you can see, 92%, 90 this, 90 blah blah blah. That's the score, that's the accuracy score, and you can always look at that and see how it progresses for different values. And as you can see, what I told you, this time we see equals 0.1 and gamma equals to 1, and it does that, then goes to gamma equals 0.1, 0.01, 0.001, and it continues till it completes the whole grid. And after that, you can check for the best parameters that give you the best score using the grid.best_params_, and then the best estimator, so using the grids.best_estimator_, does best_estimator_, right? So you can check the accuracy and other stuff of our grid search CV in this. And now we see that our grid search CV actually has an accuracy of 96%. Meanwhile, our ordinary, I was scared because this is grid's prediction. This is grid_prediction. So our grid search CV actually has 99% accuracy. Meanwhile, our ordinary SVC using the default argument gave us a 96%. That is a whooping 3% raise. So, and that's awesome. It is awesome. Yeah, many times you value, a lot of times you just realize that you value those 3% a lot. It's not, it's a lot. So basically it gives you 99%, and you can see the confusion matrix, it predicted only 2 wrong. Meanwhile the other one was predicting about 6 wrong. Yeah. So now let me do the randomized HCV. So I want to do what we just did now. I want to do it for randomized HCV. So I'm going to call it RSCV. I'm going to call it randomized HCV, an open bracket. So the first thing you specify is, you can check what you want to specify: the estimator, the parameter distribution, the number of iteration, right? These are the things you should take note of. So you can actually come here and grab this, Ctrl C, and I bring them here and I put Ctrl V. Now the estimator we are using is what? SVC. So I put SVC because we're training this based on the SVC classifier. Now the parameter distribution is what? Is our params grid. Is a params grid? Yes, our params grid, the parameter grid we created earlier, which we called, where are you? Your param grid. Let me copy this. Right, so we put param grid there. Now the number of iteration is what you need to pay attention to, because this is the number of times that your algorithm is going to, this is the number of samples your algorithm is going to take. So let me leave it as 10, and then scoring, what scoring method should we use? Let's use ROC. AC, then end jobs, we put this to be -1. Now we are putting this to be -1 so that it will make use of all the spaces in our laptop, and then we want to specify verbose. Now if you don't specify verbose, it will be running but you don't know it is doing anything. But with verbose, you just want to put something there, let's say 3. So while you start doing your rscv dot fit right, so we fit it based on the X chain and Y chain, run this, and then it's done. Is it done? Right, so it's done. It's done. Now there's one last thing I think I would have loved to show you guys that I did not show you guys. Shift tab. CV, yes, CV. Alright, so basically CV is called cross validation. Now what is cross validation? What does it do? What cross validation does is that it takes, if we say cross validation is equals to 5, alright, let's say cross validation equals to 5. What it does is that it splits the data set into 5, it trains the first 4 and use the last 5 to score it. Then it trains the remaining, it scored it with the last 5. Now it is going to score it, it is going to train the rest, leaving out the second to the last, and then score it based on the second to the last which it left out, and it will continue like that till it has done it for all the 5. Now the important thing about this is that it will help you to know, it will give you an accuracy that when you take it out there, if the accuracy should drop so much, you know you actually overfit your data. But if the accuracy is not meant to drop so much, the accuracy is meant to be good because of the cross validation. Because the cross validation will give you what to expect when your data set sees an unexpected data, or it sees a data it has not encountered before. So when your algorithm encounters a data it has never met before, it has not seen before. So let's do this. It gives you the kind of accuracy you should expect. So I run this and I run this then. And as you can see, it's saying fitting 5 folds. That's because of I said CV equals to 5 folds. So it divides into 5 and then starts fitting. And then remember the number of job is 20. So it's more or less like it is fitting for 20 times 5, because for every one it is doing what I just explained. So let's say it splits the data into 1, 2, 3, 4, 5. It trains with 2, 3, 4, 5 and tests with 1 to give the accuracy score. Then it does the same thing with 1 and 3, 4, 5. With 1 and 3, 4, 5, then it uses 2 to test the accuracy score. It does the same thing with 1 and 2, 4 and 5, and uses 3 to get an accuracy score. It does the same thing with 1, 2, 3, and 5, and uses 4. Then it does the same thing 1, 2, 3, 4, 5, and uses 5. So basically, that's what I'm trying to explain by close validation. It takes everything, it's validated, so it's not like there is one bias on one side. So then when you run that and you get this output, right, you get this output, then you can say your RSCV dot best underscore params, you remember, then underscore shift it, and it gives you what gives you the best parameter. Then you can do the same thing, RSCV dot what's that one, the best, we have best params and best estimator, but then we don't really need that. We don't need that. What we should do now is prediction. But then home pred underscore RSCV equals to, so basically I want to store the prediction that it is going to make on our S test into the pred underscore RSCV. Now we are going to evaluate it using the accuracy score and see if it is better than what you have earlier. So we have y underscore test, comma RSCV, comma pred underscore RSCV, and run this. Now you see this gives us 98%, right? Meanwhile, this gave us 99%. Now why are we having this kind of accuracy? Remember what I said earlier, that randomized search doesn't actually really go through everything. It just runs through everything randomly, right? So now I'm going to say the end number of iterations should be 75, because this actually did 75 iterations, 75, as you can see, 75 done out of 75. So hopefully, let's see if you are still going to get the same answer since we are using the same parameter grid. Alright, so best parameters. So this is what I'm saying, best parameter is what? RBF, gamma is equal to 0.0001 and 100. Let's go and check this. If it's the same thing, then we are meant to get the same output. Right, gamma is equal to 0.001, then C is 1000 and kernel is RBF, right? So C is 100 here, right? So you can see why we might not still get the same accuracy. So that's just it, and unfortunately this is what we get. Oh, so the total parameters is still random, it's 25. We couldn't get up to 75, right? So basically, as you can see, it also actually recommended that for exhaustive search you should use grid search CV. So that's that, and we've come to the end of this class. So basically, in this class, the most important thing for me is that you understand how to use grid search CV, and it is what you use to do your hyperparameter tuning, because it is actually very, very important. It can give you the best algorithm and it can give you the worst algorithm. So basically, when you do the params grid, what you do in the params grid is that you create a dictionary that takes in the argument and the list, followed by the column and a list of what you want to replace this with. So as we saw in the SVC, when you're instantiating your SVC, when you press your shift tab, so let me just bring in another SVC. I'm tired of scrolling up. So when you do SVC and you do shift tab, You can see it takes in C, it takes in kernel, it takes in degree. You can actually play with all these things. But when you understand how it works, you realize that you really don't want to play so much with these other stuffs. You probably just want to play a whole lot with these ones we've played with, which is the C, the gamma, and the kernel. So for every algorithm you need to understand what really affects it. Is it the gamma, is it the C, or whatever other thing that the algorithm takes. For example, for the K nearest neighbor, we understood that it is the number of neighbors that affects it. And I was like that. So after doing this, you pass this parameter grid into a grid search CV or a randomized size CV, depending on which one you want to do, which one you're doing. Now, what we do here is we start a randomized size CV, and the first thing we want to put is the parameter grid. The first thing we want to put is what you are using to train our model, which is SVC, opening bracket and closing the bracket, comma, the parameter grid, which is params grid, param underscore grid. And after doing that, we want to put refit equals to true and verbose equals to 3. Now the thing is, we put refit here, but even if you don't put refit there, refit is true, right? But refit is actually important, as you can see. Refit is important, so you really want to just do this. And after setting your grid search CV, you move on. So that's that, and you can read what fit does here. I tried to put in some test code here, so you can read up, and then we move on. We run our parameter grid, and then we continue from there. From there, you see your best parameters, best estimators, can be your grid search, and other stuff like that. So basically, you probably need to watch this video over again, especially the grid search CV and randomized search CV part. And then also you want to go through this notebook again. As I said, this notebook is going to be uploaded. Everything is going to be uploaded into my GitHub repository, and you can always go there to download everything. Alright, so thank you very much, and that will be the end for classifiers. But then we have other type of classifiers which you should look into. We have knife base, we have so many other beautiful classifiers you should look into. Alright, so that being said, thank you very much for watching.